Hello everyone, my name is Andrew and today I'll be going over the string library assignment for Lab 3. So chances are, since you're in 281, you've probably worked with strings before. So I'm going to write an example program here that uses a string. So I'm going to create a string str that contains the contents EECS281, and I'm going to print this string out. So as you can see here, when we run this program, we can see that str contains the contents EECS 281, and we printed the object out. So you might have seen that on line 5, we've included the string library. And what the string library actually allows us to do is it gives us a lot of operations that we can use to manipulate the contents of the strings we create. So if you go to any C++ reference website and go look at the string library, you can look at a list of all the member functions that are provided in the string library that you can use to manipulate the contents of any string you create. So for example, what we can do here, we create the string str, we can do things like insert characters, right? So for example, we can call the insert function, and all we have to do is give it a position we want to insert at, as well as the contents of a string we want to insert. So for example, let's insert the word not inside our string. What we get here is that this function, after calling it, produces the output of our new modified string with the characters not inserted at position 4. So when we run this program, we'll see that our new string has been modified to produce the output EECS not 281. Furthermore, we can also use the erase operation. Erase is another member function provided by the string library that allows us to erase characters in our string. So let's do this again, but instead of erase not that we just inserted before, so in this case, we're going to call the erase member function of the string library, and all we have to do is pass it the position we want to start erasing at, as well as the number of characters we want to erase. So in this case, let's pass in 3. And as you can see, when we print this out, that the new string no longer has not between EECS and 281, as you can see here. There are other operations that we can use. So for example, we can use replace. Replace is another member function provided by the string library that allows us to replace characters in our original string. So for example, let's replace 281 with 280. All we have to do is call the replace member function, and we can pass it in the position we want to start erasing at, the number of characters we want to replace, as well as the replacement string. So in this case, we're going to replace 4 characters starting at index. We're going to replace 3 characters starting at index 4, and we're going to replace the contents with 280. In this case, what you can see here is at the end of this replacement, the new string will be EECS 280. There are other operations that we can use to find characters in the string. So for example, find is a member function that can be used to find any substring or any contents of characters in the original string. So for example, let's call find. Let's say we want to find the position in which 280 can be found, right? At which position in the string can 280 be found? Well, all we have to do is call the find member function. So in this case, let's call find. We're going to try to find the characters 280 inside our original string. And what the result should be is the result should be position 0, 1, 2, 3, 4. The 2 here is at position 4, so we should expect that find will return the position 4. And as you can see here, when we print this out, that indeed position does return the number 4. There you go, 4. Some other operations that can be used to find characters include find first of and find last of, which work similarly to find, but instead of finding an exact match, so find looks for 280, what find first of and find last of do is they look for characters within the original string. They'll look at individual characters and find the first match that exists in both strings. So for example, if I want to find first of, and let's say I want to find first of ABCD, what this operation will do is would go in our original string and find the first instance of any character that is in this input string here. So any A, B, C, or D, whatever the first one that appears in the original string is, we're going to return the position of that character. So in this case, the first character that is in ABCD is this C here. So what's going to happen is this function should return the position of C. In this case, it would be index 2. As we can see here, when we run the program, that indeed it returns index 2 here. Find last of is another function that can be used to find characters in your string, but in this case, it finds the last instance of any character in the string. So for example, if, let's say I want to call find last of, and let's do a string 2468, what this function is going to do is it's going to find the last instance of either 2, 4, 6, or 8 in our original string. So in this case, 8 here is the very last instance of any character in this input string in our original string. So it will return the position index of 8. So in this case, this would be position 0, 1, 2, 3, 4, 5. And we can print this out and see that this is indeed the case. Find last of, return index 5. So what's good about all this is that if you include the string library, you have access to all of these member functions without having to worry about any implementation details, right? So for example, if you want to insert a substring within your current string, you don't have to worry about actually manipulating the characters in your string itself. The string library deals with that. All you have to do as a user is just call the insert function with the given parameters, and you should expect that the resultant string that you get will have this modification. Right? All the details of implementation have been abstracted away. So what is the goal of this lab assignment? Well, in this lab assignment, you're actually going to create a string object that can support these same operations here. The user can use the string you've implemented to do these operations without having to worry about the implementation details. So in other words, what you can do here is you can replace this include string with the string.h file that you'll be implementing in this lab assignment with this custom string declaration, and the program should behave the same. So if we run this program using the string.h file instead of the actual string library, you're going to see that the result is still the same, right? This insert function inserts characters inside your string, erases characters, replaces characters, and so on and so forth. But the only difference here is that you are actually going to be implementing these member functions so that they can be used by other users to do their operations. Before we begin, let's look at a few member functions and variables in your string.h star files so you'll have an idea of how to implement these functions that will tell you to implement. So if you go down to line 37, we can see the declaration of the string object here. And this is the string that the user will be able to use to create something similar to a C++ string object. So as you can see here on line 8, you can declare a string with a capital S, and it'll create a string object that should behave just like a C++ string. Furthermore, if you go down to line 185, you can see that there are a few member variables here. The two that you should worry about are CSTR and SZ. Allocation is taken care of for you. You don't have to worry about that. But CSTR is a C string that stores the contents of the underlying string object. So if you see here, when the user declares a string with the contents EECS281, this CSTR member variable would actually store a C string with the characters EECS 2, 8, and 1. And the size would store the size of this string. In this case, it would be 7. You have to make sure that these two are always consistent and that they always store what the contents of the underlying string is. Furthermore, we have a few important global members here. On line 195, we have a null byte, or you can just use the sentinel character. If you recall back from lecture or 280, every C string needs to end with the sentinel terminating character to indicate the end of the string. And this is important for many reasons. One of which is you don't want to access off the end of the string. You want to know where the C string ends so you can stop any operation you're doing at that point when you see that null character. Another important variable here is impos on line 199. And what this is actually a value, it's the max value possible that a size t object can store. Right? The size t is a number, and impos is the largest possible number that can fit in this size t. And what impos actually does is it serves two purposes. One, if it's passed in as an argument for a member function, it indicates that whatever that operation is, it should be carried out to the end of the string. So let's look at an example here, and let's look at this erase call. Right? So in this case, we have str.erase. We start at position 4, and we're going to erase 3 characters. What if you don't know how many characters you want to erase? You just know that you want to erase everything after character 4. Well, then in that case, what you can do is, instead of giving 3 as, let's say, the length of characters you want to erase, you can pass in this impos value, and what happens is it actually erases everything starting in position 4. This impos indicates that whatever the operation is, in this case erase, that it should be carried out to the very end of the string character. Impos also serves as an important return value for find operations, and it indicates that the target string you're trying to find cannot be found in your parent string. So for example, let's say on line 16, instead of trying to find 280, we try to find 370. And obviously 370 is not in our original string in any way. So what find does is it actually returns a value because it has to return a value, but this value has the value impos, or the largest possible size t value. And that indicates that 370, or the string we're passed in as input, could not be found in the string str that we're calling find on. Find first of and find last of behave similarly. So for example, if I get rid of the C here, I just want to find the first character that matches A, B, or D. There is no A, B, or D in EECS 280. So pos now becomes the value of impos, or the largest possible size t, because A, B, D are not found in our original string. So that's what impos serves as a purpose. Other than that, that's really all the information you need to begin implementing these member functions. So we're going to go over each of these operations and what you can do to implement them. All right, first, let's look at the erase operation. So the erase operation for a string takes in 2 arguments here. The first is the position that you want to start erasing at, and then it's the length or the number of characters you want to erase. So for example, let's do this first. Let's declare a string object. Let's call it str that stores the contents EECS to AT1. And let's call the erase function here. Let's erase these middle 3 characters here. We're going to erase CS in 2. So what we're going to do is we're going to call erase. We're going to start with the position we want to start erasing at. In this case, it would be index 2, because that's what the C is. And we want to erase 3 characters. And what this function should do is it should turn str into the string EEAT1. So what does it look like behind the scenes, right? So we talked about CSTR, and CSTR is a member variable. It's a C string that stores the contents of our original string. So before, the C string, CSTR, would store the characters EECS 281 and the sentinel character to indicate the end of the C string. Right, so this is the original contents of our C string value. We want to implement erase in such a way that after erase is called, actually I also want to add here that size is equal to 7. So after we call erase here, we want our desired CSTR to now hold the contents EE81 sentinel. Or we want to erase 3 characters starting in position 2, so CS in 2 will now get erased. And now we should also keep track of the size to make sure the size is correct. The new size of the string after 3 characters are erased is now going to be 7 minus the 3 characters, which is now 4. So we want to turn this C string to this C string, and we should implement erase so that it does this. Well, how can we do this? Right, so first thing to notice here is that you want to keep these characters and you want to keep these characters. These 3 characters here should be erased, but they can't just be removed in place, right? You can't just remove CS in 2 without doing anything else. Because one of the definitions of an array is that all the elements must be contiguous. You can't just have EE and then 8, 1 here, and then a bunch of junk values here. That's not something you want. What you should be doing is you should be moving 8 so that 8 ends up at this position, right? As we can see here with the desired C string, 8 should come after this E after CS and 2 are erased. And similarly, 1 should go here at this position where S used to be. And this null character should go here where this 2 used to be. So how do we do this? So we have this underlying C string here that stores EECS281. And we want to erase 2 characters. Well, starting at position 2, we want to erase 3 characters at position 2. We want to erase CS and 2. So how can you do this? Well, first, you'll have to initialize 2 indices. One that points to the first character that you want to erase, and one that points to the first character that you don't want to erase. So these are indices 2 and 5. And what you should be doing now is you should be iterating both of these indices to the end of the string. But along the way, you have to replace whatever is at the left index with whatever is at the right index. And this is to ensure that the characters remain contiguous. So what you should be doing here is you should be taking this 8 and using it to overwrite this C. So the C gets replaced with this 8. And then you're going to increment both of these indices. So now instead of looking at positions 2 and 5, we're going to look at positions 3 and 6. And we're going to repeat the process. So 3 currently points to S, 6 currently points to 1. We're going to take 1, we're going to overwrite this S with 1. So S now becomes 1. Once again, increment both of your indices. So now we're going to go look at 4 and 7. So 4 is at this 2 here. 7 is this null character. We're going to take whatever's here at index 7 and we're going to use it to overwrite whatever's at index 4. So in this case, this 2 now becomes this null character, and we increment both indices. Now you might have noticed here is that the right index now goes out of bounds, right? Goes off the end of our current C string. Our right index is now 8. And this is now larger than the size of the original string, so that's when we know when to stop. So after this replacement is done, our new C string now stores the contents E8, 1, null character, 8, 1, null character. So now the next question is, what about this stuff, right? So we've successfully moved over the characters 8, 1, and null character to replace the characters C, S, and 2, and now our C string looks like what the result should be. We also have this remaining part that we didn't erase yet. Do we have to erase these? Well, it turns out that the answer is no. And the reason it's no is because this character got moved too. When we were shifting the characters over, we end up moving the null character over to this position, which indicates that the string, or our new C string, ends at this point, and that everything else afterwards is junk values, right? You don't have to worry about this. These are no longer part of the original string. So that is the erase operation. So in summary, what you should be doing in erase is you should start with 2 indices, one that points to the first index you want to erase, one that points to the first index you don't want to erase. You're going to replace whatever's at the left index with whatever's at the right index, and you're going to continue on iterating both of these indices until the right index goes off the end. And after that, you know that the resultant C string that you get should be the C string that represents what the string after the operation should look like. Now let's look at the insert function. So the insert function takes in 2 parameters. The first is the position you want to insert, and the second is the string you want to insert. So for example, if we have the string shelf, and we want to insert the string book at position 0, what we can do is we can call insert with the arguments 0 and book. And after this operation is done, we should expect that str now has the contents bookshelf. So let's look at this under the hood. We have CSTR, our underlying C string object that stores the contents of our string. It currently holds the characters S, H, E, L, F, null character. After this insert call is made, where book is inserted at position 0, our desired outcome should be a C string that stores the characters B, O, O, K, S, H, E, L, F, and null character. So notice what insert has to do. It has to insert the contents of the new string starting at the position that you give it, and it must insert the string in this place. And notice here that we've moved characters over, right? Shelf used to start at position 0, but after book is inserted, shelf now begins at position 4. This means that we have to shift all of the original characters after the insertion point over by the number of characters in our new input string. So in this case, book has a length of 4, so we first have to move all the characters in SHELF, all the characters after the insertion point, over by 4 characters to create room for book. Let's see how this is done. So our original string currently has the characters S, H, E, L, and F. We want to allocate room at the beginning of the string, or at position 0 where the insertion should be done. We need to save 4 spots for the characters B, O, O, and K. There are 2 ways to do this. One is an incorrect way. So one method is just to shift everything over by 4 characters. So we're going to take S, we're going to move it over by 4 characters. So S now goes to the position where F is. So S moves 4 characters to the right. S now goes here. Similarly, H then moves 4 characters to the right and overwrites this null character here. Notice where things are going wrong, right? When we try to shift elements starting from left to right, we could potentially erase characters we need later, right? We need this F in the final string. But if we were to just shift S over blindly and overwrite this F is now gone, right? Same thing with this null character. We shift this H over by 4 characters, this null character is gone. So starting from the insertion position and just shifting all the characters after it by the distance of 4 is not correct. And that's because you might overwrite characters you need. When you do the shifting, you have to ensure that whatever you're overwriting has been saved and moved before, so you don't overwrite anything important. And that's done by moving in the other direction. So if we go back here, we can't move S first because there's a potential that S would overwrite something we need later. Instead, we have to move starting from the right, moving F and then L, then E, then H, and then S to guarantee that elements don't get overwritten. So in this case, what we're going to do here is we're going to start off with our original string shelf. And instead, what we're going to do is we are going to move characters over starting from the right. So we're going to start this null character here. We're going to move it to the right. This F, we're going to move it to the right. We're all going to move it by 4 characters, and that's the length of book. L moves to the right by 4. E moves to the right by 4. H moves to the right by 4. Notice that the H now overwrites this null character. But since we're moving from right to left, we've guaranteed that whatever H ends up overwriting has been shifted already. This null character is already shifted. So whatever is over here, we don't need that information anymore. So in this case, H can safely overwrite the null character without having to worry about anything. Same thing goes with S, right? S can go and overwrite this F with no problem because the F has already been moved. We don't have to worry about this F anymore because we don't need it anymore. The F has already been moved to the end. This should be an S. Now that we've moved the characters after the insertion point over by 4, or the length of the input string, in this case it's book, now we have to replace whatever is at the beginning here with the book itself. So in this case, we're going to replace S with B, H with O, E with O, and L with K. So at the end, what we have here is the string bookshelf as our underlying C string. To summarize with insert, what you should be doing is you should first remove all the characters after the insertion point. And the insertion point doesn't have to be 0, but whatever that insertion point is, you have to shift all the characters after it to the right by a distance of the length of the input string you're given. So in this case, book has a length of 4, so all characters after the insertion point, in this case for 0, have to move to the right by 4. But you have to move them in a manner that doesn't overwrite characters you need later. You can't start at the beginning and move over by 4 because you might potentially overwrite stuff that you need. Instead, you should start at the end of the string and move characters over by 4, starting from right and moving to the left to guarantee that none of the elements that you're overwriting are things that you might need later. Next, we're going to look at the replace function. So replace takes in 3 arguments. First is the position you want to replace the characters at, then the number of characters you want to replace, then the string that you want to replace the original string with. So for example, if we declare a string that has the contents EECS 281, and we want to replace, let's say, this 281 with 280, what we can do is we can call str.replace and give it the arguments we want. So in this case, you want to replace starting at position 4. You want to replace 3 characters with 280. And our new string should have the contents EECS 280. So I'm not actually going to go through the implementation of replace because it's actually something that we've done before, right? In the previous 2 functions we talked about, insert and erase, replace is actually just a combination of these 2 operations. There's really nothing else to it. Simply, instead of thinking of replacing the characters 2, 8, and 1 with the characters 2, 8, and 0, instead think of it as erasing 2, 8, and 1 and inserting 2, 8, 0 at the position that you erased before. So in other words, erase 3 characters starting at position 4, then insert 280 at position 4. And that will give you the same result that you would get if you took the long way of actually shifting the characters and doing all that stuff without realizing that replace is simply a combination of 2 functions you've implemented already. Now let's look at the 2 find operations you have to implement in this lab. The first is find first of, and this takes in a string and a position. And it looks for the first index that has a character that matches any of the characters in the given string. So in other words, it looks for the first instance of either 2, 4, 6, or 8 in the original string, EECS 281, and returns the index of this match. So in this case, the first instance of 2, 4, 6, or 8 in EECS 281 is 2. So it returns the index of 2, which is 4. So implementing this is relatively straightforward. It's just a simple double for loop. That's the simplest way to do it, in which you go through and compare each character of your original string with the character of the string that you pass in. Right, so in this case, we start with the letter E. We're going to look for if E matches 2, 4, 6, or 8. If it matches, then we return the index of E. Otherwise, we keep on going. So in this case, E doesn't match 2, 4, 6, or 8. So we go to the next E. We compare this E with 2, 4, 6, or 8. It doesn't match. C doesn't match. S doesn't match. But 2 matches with a character that exists in our target string. So because of that, find first of will return the index of 2. In this case, would be 4. 4 gets returned. Notice that you can start your find first of at any position. If you don't specify a position, it automatically defaults to 0. But you can also specify, for example, you want to start the search at index 5. And that essentially does the same thing, but instead of starting at E, it would start at 8, since that's the character at index 5. Find last of is very similar in the sense that it also takes in a string and a position, but it looks for the last instance of a character that is in the target string that you're passed in. Right? So in this case, it's looking for the last character in EECS 281 that matches 2, 4, 6, or 8. So this process is the same as find first of, except for this time you're moving from right to left. You're starting with this 1 and comparing it with 2, 4, 6, and 8 to see if it matches or not. If it's a match, return the index, otherwise decrement the index. So in this case, we start off at index 0, 1, 2, 3, 4, 5, 6. We found that 1 doesn't match with any of these characters, 2, 4, 6, or 8. So then we start looking at index 5, in this case 8. We compare it with 2, 4, 6. Oh, we see a match. So the 8 here matches with the 8 in the target string, which means 8 is the last instance or the last character in this original string that matches any of the characters in this string you're trying to find. So return the index of 5. So one common issue that people have when implementing find last of is that they do something like this, where they implement a for loop that uses I greater than or equal to 0 as a terminating condition. And one thing you have to watch out for is that this for loop never terminates. And the reason is because size t's are unsigned integers. They can never be negative, which means that the condition I is greater than or equal to 0 will always be true. So you don't want to be doing this, since in this case your for loop would never terminate. Instead, if you're using a size t in your loop, one way to fix it is to cast the size t to an integer so that you can use this condition, because then you're going to allow I to become negative. But if you want to stick with that size t variable, one thing you can take advantage of is the fact that unsigned integers wrap around. So in this case, if you end up going below 0, the size t actually ends up going back around to the very top to the largest possible size t, and that value is impos, as mentioned before. Right? So if you try to decrement 0, where 0 is a variable that's a size t, that size t variable ends up wrapping around and ends up having a value of impos. So what you can do, instead of checking I is greater than or equal to 0, because that will always be true, you can track when the string reaches the end by checking when I reaches a value of impos. Because once I reaches a value of impos, that means you try to decrement below 0, which means you've looked at all the characters when you're looking from right to left and find last of. This is covered in more detail in the specs. Please do read the specs, even though this video does cover kind of a brief overview of these functions. The specs do have a lot more detail in implementing these functions, and they're a lot more helpful with a lot more helpful hints as well. There's only so much you can get through in a video, so please look over the specs before you start the lab, and definitely start early so you can get any help you need if you have any problems. So I wish you the best of luck on this lab. Start early, read the specs, and if you have any questions, feel free to reach out during office hours and on Piazza.